Good afternoon, everyone. I, Smriti Darjee, bearing roll number 20NS0323, would like to give a short presentation on the topic JK Master Slave Flip Flop. So, the topic is new for us. Let's talk about its histories. The first electronic flip flop was invented in 1918 by the British physicist William Eccles and F.W. Jordan. So, these two were the physicists who invented first electronic flip-flop in 1918. The design was used in 1943 British Colossus code-breaking computer. So, this is a computer which is being used for this design. Such circuit and their transistorized version were common in computer even after the introduction of integrated circuit. So, not only old days only, but nowadays also, this circuit were used commonly in computer. Early flip-flop were known variously as triggered circuit or multi-vibrators. So, earlier the flip-flop were also known as trigger circuit or multi-vibrators. So, moving on to the introduction part, after getting problems, JK flip-flop, D flip-flop, T flip-flop, which gives invalid state in the execution of the circuit, to solve up that problem, we got a new flip-flop which is JKMS flip-flop, which remove the toggle problem of other flip-flop. What is JKMS flip-flop? Now let us understand. It is a type of clock flip-flop consisting of master and slave element that are clocked on compulsory transition of the clock signal. Data is only transferred from the master to the slave and hence to the output after the master device output have stabilized. Talking about its principle, firstly, the master-slave flip-flop is positive triggered and slave flip-flop is negative label triggered. So, the master responds before the slave. If J equals to 0 and K is equals to 1, the high Q dash output of the master goes to the K input of slave and the clock forces the slave to reset. Thus, the slave copies the master. Let us know more about master-slave flip-flop, JK flip-flop. JKMS is basically a combination of two JK flip-flop connected together in a series configuration. Out of this, one acts as a master and the other one acts as slaves. The output from the master flip-flop is connected to two input of the slave flip-flop whose output is feedback to input of master flip-flop. The circuit is an inverter, includes an inverter. The inverter is connected to pulse in such a way that inverted clock pulse is given to the slave flip-flop. So, how does it works? Let us understand how does it works. A master-slave flip-flop can be constructed using two flip-flop as shown in figure. So, master-slave flip-flop is not different flip-flop, but simply we can construct it by two JK flip-flop, and master-slave flip-flop basically is introduced because to remove the drawback of JK flip-flop. So, in this, there will be two JK flip-flop in which one acts as master and another acts as slave. Basically, slave flip-flop copy the output of master flip-flop. So, the first flip-flop called the master is driven by positive clock, and the second flip-flop called slave is driven by the negative clock. So you see a figure with blue pen, that is clock pulse. When the clock pulse is a positive clock, then master flip-flop will run, and due to this it will operate, and the slave will operate due to negative pulse of the clock. So this is how it works. During positive clock, master flip-flop gives intermediate output, but the slave doesn't respond. So when the positive clock, like when you apply positive clock or when there will obtain positive person, the master slave will get active. And remember, this is not the final output where the master flip-flop gives. From this, we will obtain intermediate output. So, during negative clock, slave flip-flop active and it copy the previous output of master flip-flop and produces final output. So, now negative clock, the negative person during negative clock, in this case the slave will get activated and the master will get deactivated. Basically, the output of master will be work as input of slaves. So this is a figure which shows a master slave JK flip-flop constructed using NAND gates is shown in this figure. So you see here a triangular slave in a bottom with small circle is represented as NAND gates. So it is also called master slave JK flip-flop constructed using NAND gate. Sometimes it may came in exams to draw. So some of the example for this circuit is when the clock input is 0, the output of inverter is 1. The slave latch is then enabled and it Q is equal to the master latch output. The master latch is because clock is 0. When the logic 1 clock pulse is applied, the value of S and R control the value in the master latch. The slave is disabled as long as the pulse remain at the 1 because its clock input is equal to 0. Any changes in external S and R change the master output but cannot affect the slave output. When the pulse returns to 0, the master is disabled and is isolated from S and R input. At the same time, the slave is enabled and the current value of master output is transferred to the output of flip-flop. To solve up the problem occurred in JK flip-flop and solve up race around condition which occur in other flip-flop. So this is the truth table for JKMS flip-flop. From this circuit we can obtain this truth table. like we have done previous as an example as well. So, results. As a result, master configuration is used in flip-flop to eliminate the race around condition but not to store 2 bit of information. Talking about merits and demerits, that is advantage and disadvantage of JKMS flip-flop. Master slave configuration helps to control race around condition from JK flip-flop when we put J and K as 1. So I'm talking about merits. So it overcome the main drawback of JK flip-flop and SR flip-flop. The master slave configuration has the advantage of being edge triggered, making it easier to use in larger circuit since the output to the flip-flop often depend on the state of its in output. It is easier to design sequential logic which is controlled by one edge rather than two levels. Talking about the demerits or disadvantage of JKMS flip-flop, master slave pulse triggered flip-flop, so zero complicated. It create more head changes. It is as reliable as single processor system. That is, if the master slave processor fails, the entire system fails. There would be situation when the slave processor would be free from the master processor could assign them tasks. So talking about application of JKMS, where let those devices in which JKMS are applicable is frequency divider, counters, storage, shift register, data storage, bounce elimination switch, latch, data transfer. So it has practical application as well. The IC circuit consists of a lot of stages of digital circuit where timing of data appear at the input of flip-flop and obtaining the output from flip-flop is very much vital in performing those circuit performance of successive stage of digital circuits. So I hope you like this presentation and thank you for listening me.